All right, so looking at number 1, we want to find the slope, distance, and midpoint. Leave your answer in simplest radical form. So you guys have to know these formulas. You got to know your slope formula, your distance formula, and the midpoint formula. Our slope formula is what? Awesome. y2 minus y1 over x2 minus x1. What about the distance formula? The square root of x2 minus x1 squared plus y2 minus y1 squared. Awesome. And then lastly, our midpoint formula is what? Awesome. x2 plus x1 over 2, comma, y2 plus y1 over 2. So it's the average of the x's and the average of your y's. Remember, your midpoint is going to be a point. When you're adding, it doesn't matter the order that you add them in, because x2 plus x1 is the same as x1 plus x2. But when you're subtracting, the order matters, so just be careful. Let's do A. So let's start with our slope. I think it's super helpful, label your points before you plug them all in. So I've got x1, y1, x2, y2. So when we plug it in, we have 6 minus 0 over negative 3 minus 1. So this gives us 6 over, what's negative 3 minus 1? Negative 4. And then always make sure you simplify as much as you can. What would this simplify to? Awesome. So negative 3 over 2. Next, let's find the distance. So our distance would be the square root of, let's plug it all in. So we have x2 would be negative 3 minus x1, which is 1 squared, plus y2, which is 6, minus y1, which is 0 squared. So we have the square root of negative 4 squared, plus 6 squared. So the square root of 16 plus 36, which would be the square root of 52. Let's see if we can simplify our radical. What are 2 factors of 52? 13 and 4, that works. Or if you said 2 and 26, that would work too. We can break down the 4 some more. What are 2 factors of 4? 2 and 2. So what would come outside of the radical? 2. What stays on the inside? 13. So 2 square root 13 would be our distance. Make sure you simplify your radical if it can be simplified. Next, let's find the midpoint. So I have x2 plus x1 would be negative 3 plus 1 over 2. And y2 plus y1 over 2, so 6 plus 0 over 2. Negative 3 plus 1 would be negative 2 over 2. 6 over 2, this would simplify to negative 1 comma 3. So that would be our midpoint. All right, let's look at number 2. We want to find the slope, the y-intercept, and graph. How would I find the slope here? Awesome. We want to put this into y equals mx plus b form. So we want to move everything to the other side, get the y all by itself. So I'm going to add the x and subtract the 9 to the other side. So we have 3y is equal to x minus 9. What would we do next? Divide by 3. So everything gets divided by 3. We have y equals, how else could I write this as x over 3? How else could I write that? so we could see our slope. Awesome, 1/3 x minus 3. So what's our slope? 1/3. And then what is our y-intercept? What's our b? -3. Let's graph that. So we always want to start by graphing our y-intercept. We're going to go down to -3, put a point there. And then our slope is 1/3, so that is rise over run. We're going to go up 1 to the right 3. You can put a couple points if you want to, but you really only need 2 to draw a straight line. We're going to go up 1 to the right 3. So our line would look like this. We want to determine if the lines are parallel, perpendicular, or neither. What do we know about the slopes if the lines are parallel? They're the same slope. What do we know about the slopes if they're perpendicular? Opposite reciprocals. Meaning that the signs are different and they're flipped. So for B, we want to find the slope of each line and then compare them so we can see, are they the same slope? Are they opposite reciprocals? If they're not the same and if they're not opposite reciprocals, then it would be neither. So let's find the slope of each line. So starting with line 1, we've got x1, y1, x2, y2. So our slope formula, y2 minus y1 over x2 minus x1. So this would be -7 minus -16 over 0 minus 1. Minus a -16 turns into plus. So what's -7 plus 16? So 9 over -1, which would simplify to -9. Let's find the slope of line 2. So again, I'm going to label x1, y1, x2, y2. So 11 minus -7 over -1 minus 1. This turns into a plus. So 11 plus 7 would be 18 over -2. What does this simplify to? -9. So would these be parallel, perpendicular, or neither? Parallel. Why are they parallel? Because they have the same slope, so they would be parallel. All right, for number 4, I want to do B. So it says write the equation of a line in slope-intercept form that's parallel to our given line and through the point 4, 2. So if it's parallel to the given line, what do we know about the slope that's parallel? Same slope. But we got to find the slope of this line first. How would we find the slope? Subtract the 6x over. We want to put it into y equals mx plus b form. We're going to rearrange it first to find what our slope is. So we have 2y equals, when I subtract 6x to the other side, we get -6x plus 4. What would we do next to get the y all by itself? Divide by 2. So y equals -3x plus 2. So what's our slope here? -3. Awesome. Our slope here is -3. So the slope of the line that's parallel to this one is also -3. It's going to be the same thing. The rest of this equation does not matter. We are only looking at the slope. And since it's parallel, we know that the slope is going to be the same. What if this question said, what if it asked for a line that was perpendicular? What would the slope of our perpendicular line be? Awesome. Our perpendicular slope would be 1/3, positive 1/3. Perfect. But the question's not asking for perpendicular. If it was, you would find the slope and then take the opposite reciprocal of it. But let's go back to this question. So we found our slope. What would we do next to come up with our equation of the new line? plug in into what? Point slope, because we've got a point and we've got the slope. So our point slope form is y minus y1 is equal to m times x minus x1. So our point's going to be x1, y1, and our slope is the m. So y minus 2 is equal to negative 3 times x minus 4. Now, does this question specify what form we have to leave our answer in? Yeah, it says write the equation of a line in slope-intercept form. Is this slope-intercept form? No. So we got to simplify it to slope-intercept form. Dominic. If it doesn't say, if it just says find an equation of a line, you can leave it in this form. But if it says slope-intercept form, what do we have to do? Distribute. We want to distribute. We got to make it y equals. We got to get the y all by itself. So y minus 2 is equal to negative 3x plus 12. What would we do next? Add 2. Perfect. So y equals negative 3x plus 14. So we want to find the domain, the range. We'll go increasing, decreasing, and constant. So starting with our domain. Remember, our domain is the x values. So if I take my pencil and I hover it over the graph starting at the left side, what are the smallest x values that my graph touches or goes to? Negative infinity. This is going to the left forever. So it would be from negative infinity. So I'm still hovering my pencil over my graph. Does it stop anywhere? Stops at 1. Perfect. So if I take my pencil and I hover it over my graph, it's touching graph because this is going forever to the left. It's touching graph until we get to 1. Both of these are open circles, so I've got a gap at 1. So I would say from negative infinity to 1. And then my graph starts up again at 1, so I would put a union because we've got 2 parts. And then it goes to what? It's touching graph until where? 4. Until 4. So from 1 to 4. Would 4 get a parentheses or a bracket? Bracket because it's got a closed circle. Any questions here? Let's do the same thing for the range. So our range, we're going to start at the bottom. My pencil starts touching graph at what number? Negative 1. Bracket or parentheses? Bracket. Since this is not an open circle, our graph touches negative 1. So we'd put a bracket, negative 1. My pencil's touching graph. It's still touching graph even though we've got a gap here. We're still touching the graph over here. So it's still touching graph. Till when? To infinity. So this part is included in that negative 1 to infinity because my pencil is touching graph. It doesn't matter if it's touching 2 parts of the graph. That's fine. Still touching graph to infinity. So negative 1 to infinity would be our range. We okay with that too? Does that make sense? Any questions there? All right, let's find our increasing, decreasing, and constant. So just like you read going from left to right, we read our graph going from left to right. Would I be walking uphill or downhill at the start here? We're walking downhill, so we're decreasing until when? Careful. At what x value do we stop decreasing at? 0. So remember, increasing, decreasing, and constant is x values. We're decreasing from negative infinity to 0. So even though this looks like negative 1, we're talking about the x values for increasing, decreasing, and constant. X values. So from negative infinity to 0, would 0 go to bracket or parentheses? Why parentheses? It's always parentheses for increasing, decreasing, and constant. Always parentheses. Oops, sorry, that's decreasing. I put it in the wrong spot. Negative infinity to 0. So then at 0, I start walking uphill again. Till when? What's the x value? At 1. So from 0 to 1, I'm increasing. And then here, we jump up to this spot. I'm still walking uphill, so I'm still increasing. So I'd put a u, because we've got 2 parts that we're increasing. From 1 to what? 1 to 4. Remember, we're looking at the x value from 1 to 4. So because we have a gap in our graph, we got to show that gap in our increasing intervals. So we're increasing from 0 to 1, but then also from 1 to 4, the x values. I think on WebAssign you put DNE, but just don't put anything if you want to. You could say no, NA, whatever you want. So for C, let's do our domain, range, increasing, decreasing, constant. So our domain, talking about x values, we're going from left to right. What would our domain be? Negative infinity to infinity, perfect. So our graph is going forever in the left direction, forever in the right. So negative infinity to positive infinity. What about the range? Same thing. It's going down forever and up forever. So it would be negative infinity to positive infinity. Then let's find our intervals of increasing, decreasing, and constant. We'll start at the left side. We're walking uphill, so we're increasing first. So remember, we're looking at the x value. So this is the left side of my graph. So I'm starting at negative infinity. We're increasing till about here, which we could say is negative 1.5. It's not really on a number exactly, but remember, x values. So we are increasing from negative infinity to negative 1.5. The quiz will be more clear with the numbers. Bless you. Then here we start walking downhill, so we're decreasing to what x value? So I could say negative 1.5 to 3. And then at 3, we start increasing again. Till when? To infinity, perfect. So that would be increasing. We're going to put a union since we have more than one set. So from 3 to infinity, we're increasing. So we're not constant anywhere. So for our range, if we start at the bottom, our graph or our pencil would touch graph at negative 1, but it actually doesn't, it doesn't go anywhere. So it would just be negative 1. So it would just be negative 1 in brackets. And then we start again at 0. So bracket 0 to infinity. So if I hovered my pencil over my graph, it touches at negative 1, but just at negative 1. And then it skips to 0, and then it goes up to infinity. Let's do the domain too. So our domain is the x value. So starting at the left, our graph points forever in the left direction, so it'd be negative infinity. Then if I hover my pencil over my graph, starting at the left side for our domain, goes forever to the left. It's touching graph, touching graph, touching graph. Here, it's still touching graph because this one's a closed circle. So we're still including 2 in our domain. And then we touch graph all the way to infinity. So it'd be negative infinity to positive infinity. So when it's an open circle and a closed circle, they overlap. Here, we did, in A, they were both open circles, so we had to show that gap in the domain. So make sure you notice the difference between this gap and this gap. This one is both open circles, so we have to show the gap in our domain. This one, this bottom one's a closed circle, so it's included, so we would include it in our domain. So you don't have to show that skip. They're not going to be both closed circles because then that wouldn't be a function. Let's look at B. So we've got 3 pieces to our graph here. We're going to graph one piece at a time. So starting with our first piece. What do we know about this piece? What's the shape of our graph going to be? It's going to be what? A line, but what type of line? If I just had y equals 0, what type of line would we have? What type of line? Horizontal line. Awesome. It's constant. There's no x. There's no slope. So it is a constant line. It is going to be horizontal. So just keep that in mind. Let's find some points. What number would we start plugging in here? Just remember, we always want to start with the numbers that it gives us. So we're going to start by plugging in -5 and -2. So if I plugged in, hypothetically, because we really don't have anywhere to plug in here, if I plugged in -5, what would our y be? 0. Y is always 0 for this piece. At this point, is it an open or closed circle? Closed, because it's less than or equal to at the -5, so it'd be a closed circle. So we're going to go to the left -5 and stay at 0 and put a closed circle. We're going to do the same thing with -2. What's our y when we hypothetically plug in -2? It would be 0. And open or closed circle? Open circle, because it is just a less than sign. So we're going to go to the left to -2, put an open circle there, and we're going to connect our dot to the horizontal line. So that would be our first piece. Let's do the second piece now. What do we know about the shape of the line in our second piece? It's a parabola. We know that it's a parabola. So what did we say when we did the notes that we have to do when we have a parabola? Graph at least 3 points. We need at least 3 points when we're doing a parabola. So here it already tells me which 2 I want to plug in. So I'm just going to plug in something in between those 2 as well. So let's start with -2. So we have -2 squared plus 4. Now make sure you follow your order of operations here. You got to square the -2 first, then multiply it by the negative on the outside. So this would be -2 squared is 4. That negative on the outside makes it -4. So -4 plus 4 would be 0. So I plugged in -2 and got 0. Is this an open or closed circle? It is a closed circle, perfect, because it's less than or equal to, so closed circle. So I'm going to go to my graph, go to the left to -2, stay at 0, and put a closed circle. They overlap, but that's fine. What should we plug in next? Let's plug in 1. So when I plug in 1, I have -1 squared plus 4. Remember that negative is on the outside, so I got to square the 1 first, then multiply it by the negative. So this would be -1 plus 4, which would be 3. So we plugged in 1 and got 3. Is this an open or closed circle? Closed circle. So I'm going to go to the right 1 and up 3. Put a closed circle. Now we can't just connect these points with a line. We said this is a parabola. It depends on which piece of the parabola we're talking about. So we want to plug in some number in between -2 and 1. What do you think a good number to plug in would be? 0. Let's plug in 0. Great choice. So you have -0 squared plus 4. That would just be 0 plus 4, which is 4. So when I plugged in 0, we got 4. Now this piece is just showing us the shape of the graph. It's giving us direction to connect our points. So it's not a defined open or closed circle. So I'm going to stay at 0, go up 4. Once we have 3 pieces, we can draw our graph. We know that the shape's going to be a parabola, and we see that it's going to go up and then down. So it'll be something like that. If you want to plug in more points to get a better idea of the shape, you can. But make sure you plug in at least 3 when you have a parabola. Any questions on our second piece here? Let's do the third piece now. So what should we plug in first with the third piece? 2. Awesome. We always want to plug in the number that it gives us. So we're going to plug in 2. So we have -2 plus 3 would be 1. So we plugged in 2 and got 1. Is this an open or closed circle? Open. So I'm going to go to the right 2 and up 1 and put an open circle there. What's the shape of this graph? It's going to be a line. So we know we only need 2 points. So what else could we plug in? Sure, we can plug in 3. Anything greater than 2. This one's written a little bit backwards, but it says 2 is less than x, so x has to be anything greater than 2. So we can plug in 3. So we've got -3 plus 3 would be 0. So we plugged in 3 and got 0. Now remember, the second point just gives us direction. We don't have a stopping interval here. X could be anything greater than 2, so we're going to have an arrow. So we're going to go to the right 3, stay at 0, and then we can connect our points with a line. Any questions here?